Okay, over here we're going to try to find tangent inverse of 1, and I'm going to say the tangent inverse is theta. So the output of, a, of an inverse trig function can be thought of as an angle. And this is the same thing as, this means tangent theta is equal to 1. Now for all the inverse trig functions, if the input is a positive number, then our output is going to be an angle in quadrant 1 between 0 and pi over 2. So, well, we have to figure out when tangent is equal to 1 in quadrant 1. So, okay. One of the ways you can think of tangent is that tangent theta is equal to y over x, and that's the same thing as slope. So what I mean is the slope that of the line segment from the center to the circle, the line of the radius of the segment, of that segment, from the center to the circle. So what does a slope of 1 look like? Well, that, I think we know without really thinking all that much, is going to come at a 45-degree angle. So that's a quick way to know that. My picture was not really all that good on that, sorry. Oops. So, okay, I'm going to do better this time. All right, so this is, this has slope 1. 45 degrees, slope 1. That's one way to look at it. Another unit circle approach is to list these numbers. However, when you're thinking, well, tangent's y over x, this means, and if it's equal to 1, this means the x coordinate and y coordinate are the same because y divided by x is 1, so the x and y have to be the same. So that corresponds to this rad 2 over 2, rad 2 over 2. So yet another way to do this is to draw a right triangle. So tangent is equal to 1 over 1, and tangent is opposite over adjacent. So you can write 1, 1, a right triangle, and then you hopefully will recognize this right triangle as corresponding to pi over 4. And so therefore, finally, both ways tell us that we have this answer here. And that's our answer. Okay, I mean, a lot of people just memorize tangent pi over 4 is 1. Now let's look at a follow-up. This wasn't one of our exercises, but tangent inverse negative 1, and we'll just do a follow-up. So this corresponds to tangent theta equals negative 1. Now, by the way, for whatever reason I forgot or something, that theta then for tangent is between pi over 2 and negative pi over 2. That's the output, the range of tangent inverse. So the places we're allowed to look anyway, and maybe I'll just use the same picture twice, but we'll see. The places we're allowed to look for our answers or our output for tangent inverse are only between negative pi over 2 and pi over 2, not including pi over 2. Maybe I'll leave off that circle, but it's not including pi over 2 because tangent pi over 2 is undefined, tangent negative pi over 2 is undefined. Okay, so again, we're looking over here back to this, that theta is between negative pi over 2 and pi over 2. Now, if I'm thinking about slope again, which I will do, that's the way I like to think about this because I think it's quick, then I can draw a line with slope negative 1. And that is going to also give a 45-degree angle, and that's going to give negative pi over 4. So viewing this as slope makes the whole thing go really quickly. Also, if tangent theta is -1, that means that the y and x coordinates have to have opposite signs of each other. And that would correspond to what I'm writing here, which rad 2 over 2, negative rad 2. So that also gives negative pi over 4. We can use the triangle, the right triangle, to only get the reference angle, but it's not going to give us the fact that it's negative pi over 2, but the reference angle works also. So anyway, our answer is that tangent inverse of -1 is equal to negative pi over 4. And color that in, highlight that. Okay, that's all.